How do we solve separable differential equations? In this video, I will give you guys 6 examples of separable differential equations. And this is meant to be an introduction to differential equations for Calculus 2 students, so we won't get into too many details. But here's the first one. Notice, because we have this right here, which is called the initial value, the whole thing right here is actually called the initial value problem. And to solve this, we are going to first bring all the x and the dx together on one side, and all the y and the dy together on the other side. So you see, right here we have the square root of y plus 1. We can put that to the other side by dividing this on both sides. So we get 1 over square root of y plus 1 with the dy here. And then we can just multiply the dx on both sides. So we get cosine x dx like so. And you see, y and the dy are together, and the x and also the dx together. So this is good, because now we can just integrate both sides. How do we integrate that? Well, let me show you guys on the side real quick. Integral of that 1 over square root of y plus 1. We can just do a u sub real quick. Let u equal the inside, which is y plus 1. And we see du is just the same as dy. And this right here is just the integral 1 over square root of u du, which is the same as saying integrating u to the negative 1/2 power in the u world. Well, to integrate this, we'll just add 1 to the power, which will give us positive 1/2, and divided by the new power, which is the same as multiplied by 2 over 1. And we will just get 2 times the square root of u, which is y plus 1. And right here, you don't have to worry about the plus c. Technically, you put on plus c here, but you also will put on plus c here. However, you can bring the constant from the left-hand side to the right-hand side, and the two constants together is still another constant. So I'm just going to write down the result right here, which is just that. 2 square root of y plus 1. No need for plus c, just do it on the right-hand side. Integrating cosine, we get positive sign, and then let's go ahead and put down our constant. This is the first constant, so let's label that C1. Because you will see, to isolate the y here, let's go ahead and divide everybody by 2. I'm showing you guys this step is because of this part right here. But anyway, we get square root of y plus 1 being equal to 1/2 sine of x, and then here we go. C1 is a constant, 2 is a constant. A constant divided by another constant is just another constant. So we are going to label this as C2. Yep. And then let's go ahead, square both sides. So you see this and that will cancel, and this is going to be y plus 1. We can put a 1 to the right hand side. So we get negative 1 plus this thing, which is 1/2 sine of x plus c squared. And the reason I just write down c is because we are done. The left hand side will just have the y by itself. Remember, the one is right here already. This right here is called the general solution. So we can just present the answer right here with the c without the subscript. Well, you also have to keep in mind that y is a function of x. So let's write this down, y as a function of x. Now, because we have this initial value, which says y of pi is equal to 0, that means we can just put pi into this x here and then solve for c. So we get negative 1 plus parentheses 1/2 times sine of 0 and then plus c, and then square. Okay, look at this equation. Bring the negative 1 to the left hand side. We get 1 equals, this is just 0, and then we have c squared. What's c? We'll do the square roots on both sides, and don't forget the plus or minus. So c is actually equal to plus or minus 1. So in fact, we have 2 answers, right? Because the first answer is with positive 1, and the second answer is with the negative 1. So that will be pretty much it, and let me write down the final result for you guys. First, we have y of x being equal to negative 1 plus 1/2 sine of x, and then c is positive 1, so we just add a 1 here, and then we square. The second one, we have y of x equals negative 1 plus 1/2 sine of x, and then minus 1, and then square. this and that, they will both satisfy the initial value problem. So they are both the answers. All right, here is our second problem. Well, we see that we have e to the y here. We can divide this on both sides, right? So we get 1 over e to the y on the left-hand side together with the dy. And then, of course, we can bring this to the right-hand side. So we have 1 over x squared plus 1 dx. And now we can all be happy because we can just integrate both sides. So do it here, almost one color. Do it here. And then integrating this, have a look here. E to the y on the bottom is the same as e to the negative y. And of course, you can do a u sub real quick. Let u equal that. And you see, du is just going to be negative 1 times dy. It's just a constant, right? Negative 1. So that's good because this right here is just going to be e to that power and divided by the derivative right here, which is the negative 1. And you can do this whenever the inside function is just a constant. So this right here is just negative e to the negative y. And then just put a constant on the right-hand side. So this is equal to the integral of this is inverse tangent of x. And then here we go, plus constant. And maybe that's already a c1. Okay, here we have a negative. So perhaps let's divide everybody by negative 1. This is a lot of fun right here, right? And then cancel this out and we get e to the negative y being equal to negative inverse tangent of x. Here we go. C1 is a constant, negative 1 is a constant. When they divide, you just get another constant. So therefore, let's just put down plus C2. How cool is that? Okay, I want to solve for the y right here. First, we take the natural log on both sides. So we get ln of the whole thing inside. So negative inverse tangent of x plus C2. That will give us negative y, so we can divide the negative on both sides. So we make this negative, and then we can get the y by itself. That's pretty much it. So in fact here, I am just going to label that as c. We don't need a subscript anymore. And then right here, we can write it as y as a function of x. Now, we have this initial condition. Y of 0 is equal to 1. Sorry, negative 1. And we have the right-hand side, that's negative ln, parentheses, negative inverse tangent of 0 plus c. Have a look. Negative, negative, so we just get positive 1 equals positive ln. Inverse tangent of 0 is 0. Multiplied by negative is still 0. So inside here is just c. ln of what will be 1? E, right? You can just do e to this power, e to that power if you like. And then we get c is equal to e. A lot of letters. Alright, so we are done pretty much. So we get y of x being equal to negative ln of negative inverse tangent of x, and then plus not c, but rather we have e. Okay, and then here is the solution to that initial value problem. Okay, take a look at number 3 right here. We have dy dx is equal to all this. Be sure you do not minus the y on both sides, minus the x on both sides. No, don't do that. What we will have to do is look at the right-hand side and then try to factor it. And hopefully we have a factor in terms of just x and then the other factor in terms of just y. Well, let's see if we can make that happen. We have 4 terms right here. Do the good old business, namely factor by grouping. Look at this and look at that. Well, this and that we can factor on x and then we will get y plus 2. That's really good because you see, this is also y plus 2. But right here, technically, you can say plus 1, factor of 1, and then we have the y plus 2. If you look at it this way, you see that we can factor out the y plus 2. And then the other factor is just x plus 1. Very nice, huh? And perhaps I'll just match the color right here. And now we have dy dx is equal to that. We can just divide this on both sides. So we get 1 over y plus 2 with the dy. And that will be equal to this right here is still on the right hand side. And then let's bring the dx right here. Aha! We can then integrate both sides. Do it here, do it here. On the left hand side, we get ln, absolute value of y plus 2. And again, c will just be on the right hand side. Integrating this, we get 1/2 x squared plus x, and here we go. This is the constant. Now, to get the y by itself, let's do e to the power and e to the whole thing right here. Cancel, cancel, and then we have absolute value of y plus 2. Check this out. E to this power, and they are all adding. I'm going to break it down as e to this power. So let's write that down, which is e to the 1/2 x squared plus x. That's just the function part. And then I'm going to look at e to the c1 right here. So I'm going to say e to the c1. And of course, if you look at it backwards, this times that, you just add the exponents. So that's what we have. Here we go. C1 is a constant. E is a constant. A constant to a constant is just another constant. So we are going to look at this and label that as C2. Alright. Now, let's think about how we can get rid of the absolute value. You literally just get rid of the absolute value, but you will have to put a plus or minus on the right hand side. Okay, that's pretty good. And now I'm going to write down the work right here. We have y plus 2. We can put a 2 to the right hand side. So we get y by itself now. And then that will be equal to -2. Right? Put a 2 to the other side. Here we go again. This was labeled to be C2 earlier, but you see, positive C2 is a constant, negative C2 is it's just a constant. So together, we're just going to label that as C3. So I'm just going to say plus C3. And then we have e to the power, so let's just write that down, e to the 1/2 x squared plus x. And because we got the y by itself, we don't need to have the subscript anymore. So this right here will be our c for the general solution. Let's make it slightly bigger. And we know this is y as a function of x. Okay, we know this right here, so let's go ahead and solve that. So y of 2 is equal to 0. And this means x is equal to 2. Plug in here. So we get -2 plus c, and then do e to the 1/2 times 2 square, and then plus 2 power like that. Let's bring the -2 to the other side. We get 2 is equal to, and this is c, and this is e. Check this out. This is going to be 4. Divided by 2 is 2, 2 plus 2 is 4, so this is e to the 4th power. Okay, so how do we get the c? Divide e to the 4 on both sides, so you see that c is just going to be 2 over e to the 4th power. So, we can then put this back here. Ladies and gentlemen, we are looking at y of x being equal to -2, and then the c is that, which is plus 2 over e to the 4th power, and then we have all that, which is e to the 1/2 x squared plus x. But you see, this right here has the base e, likewise that. So perhaps we can just do this power minus that power. So I'm going to write this down. Y of x being equal to -2 plus just a 2 right here, and then e to the 1/2 power times x, e to the 1/2 times x squared plus x, and then minus the 4. Yeah, just like this. Okay. Done. I like number 4 a lot. Check this out. dy dx is equal to y times L and y. Divide this on both sides. We get 1 over y, L and y, and then we have the dy here, and that's equal to dx. Right? And then integrate both sides. Of course, integral. Integrating left hand side, we get what? Now let's do it on the side. We can just do u sub. Let's do it together right here. Let u equal L and y, so let's go ahead and make that happen. Differentiating this, we get du equals 1 over y dy. And we have that right here, right? 1 over y and also the dy. That's so good. And you see this is just integral 1 over, this is the u. And then the rest right here produce the du. So this right here will give us ln absolute value of u, which is that, ln y. Cool. So on the left hand side, we get ln absolute value of ln y. Don't worry about the constant, just put it down on the right hand side. Integrating dx, we get x, and then here we go, plus c1. Here we go. E to the power, cancel. Absolute value of L and Y is equal to e to this power times e to the power. Here we go. C1 is a constant, E is a constant to a constant is just another constant. So let's label this as C2. Alright, and then we are going to get rid of the absolute value. And remember, we will have to put down a plus or minus. And we see that the left-hand side gives us L and Y. And here we have plus C2, which is a constant. Negative C2 is a constant. So let's just label that as C3. And then we have e to the x. Cool. And now we will just do e to the power again. Cancel. So we get y by itself. And then on the right hand side, we get e to the power. So I'm going to just write it down e. And then we have the c3. But the y is isolated. So I'm just going to put it down as c. And then we have e to the x power like that. Okay, so y as a function of x. This right here is a general solution for that. With that though, we know y of 0 equals pi, and we'll just put a 0 into this x here. So we are looking at e to the c times e to the 0. This is pi, that's good. E to the 0 is 1, but look at this as e to the c though. Right here, wow, where's the number? There's no more number, oh my goodness. By the way, ln both sides, so that we can get rid of this. So c is equal to ln pi. So we can put that down right here. Ladies and gentlemen, y as a function of x is equal to e, and then we have ln pi times e to the x power. You can just leave it like this, but I'm going to show you guys what's even cooler than this. You see, right here we are multiplying two powers. What we can do is the following. We can look at e to the power of ln pi first, and then raise to the e to the x power. Because you see, when you multiply powers, that's exactly this situation. E to this power, and then raise to the power, you just multiply this. So I'm just kind of like looking at this backwards. Why do we do that? Well, it's because e and ln cancel, and you will just end up with pi, and then e, and then to the x power. Wow, that is the solution to that differential equation with some initial condition. Number 5, dy dx is equal to all this. Notice, we have cosine squared y. We have to factor that out first. So that's going to make that happen. Cosine squared y, and then times, the rest will be just x plus 1. Okay, divide this on both sides, so we get 1 over cosine squared y with the dy here, and that's equal to parentheses x plus 1 with the dx here. Okay, this right here, integrate, this right here, integrate, but what's 1 over cosine squared y? Secant squared y. So again, this right here is actually just secant squared y, right? 1 over cosine secant, and then we have the second power. So when we integrate secant squared, we get tangent. The left-hand side gives us tangent, and this is the regular tangent, and the input is y, and then the right-hand side, we get integral this, which is 1/2 x squared plus x and plus c. C is enough. You'll see why. Because I want to get the y by itself, we can just do the inverse tangent on both sides. Y as a function of x will just be inverse tangent of the entire right-hand side, and that's 1/2 x squared plus x plus c. Cool. Okay, y of 0 is equal to pi over 4. Alright, so let's see. Y of 0 gives us pi over 4, and we have inverse tangent of, and this is going to be 1/2 x is 0, and then another x is 0, and then we have the c. So we are looking at pi over 4 equals inverse tangent of C. Okay, inverse tangent of what will give you pi over 4. You can look at this backwards. C is just going to be tangent of pi over 4, which is just equal to 1. Yeah. Or if you would like, you could have solved the differential. You could have solved the C right here. Might be easier. But I want to do it this way because that way we can talk about the general solution, especially when we have the y isolated. Yeah. Okay, so we have C is equal to 1, and now we can just write down the answer. And ladies and gentlemen, our answer is y of x equals inverse tangent of 1/2 x squared plus x plus 1. Done. Okay, number 6, dy dx is equal to y plus y squared. Of course, we will have to bring both of them to the other side by dividing. So we get 1 over y plus y squared, and then we have the dy here, and we'll just multiply the dx right here. That's what we have. Integrate both sides, right? But how do we integrate this? Notice on the bottom, we can actually factor it. So when we do that, we get y times 1 plus y. So we do partial fractions, yes. So right here, we are looking at the integral of some number over y plus some other number over 1 plus y. And then we are in the y world. And perhaps let me just leave the integral right here on the right-hand side too. To figure out this number, we go back to the original and cover the same denominator. How can we make y equal to 0? Y has to be 0. And we put 0 into this y here. And we get 1 over 1 plus 0, which is just 1. Good. Now, look at this right here. Right? To get this right here, we cover the same denominator. And how can we get this equal to 0? Y has to be negative 1. Put it here, 1 over negative 1, we get negative 1. Great. So integrate now, we get ln absolute value of y, and then minus ln absolute value of 1 plus y, and that's equal to x plus c1. Cool. So we are done with the integration, and then the rest is just algebra. And let's just go ahead and solve for y, because again, I want to look at the general solution first before we solve for the constant. So to get that happen, we are going to combine logarithms first. So we get ln absolute value, this over that, y over 1 plus y. And that's equal to x plus c1. And then do e to the power, cancel this out. So we get absolute value of y over 1 plus y equals e to the x, and then times e to the c1. This right here, again, is just c2. And then get rid of the absolute value, put a plus or minus, like the good old business. Draw a big arrow, and then the left-hand side is that y over 1 plus y, and that will be equal to, you know the deal. Those things together is just c3, and then we have e to the x power. Very nice. Now, to get the y by itself, let's multiply this equation by the denominator, which is just 1 plus y. And we will get y equals, distribute, we get c3 e to the x times 1, and then this times that, so plus c3 e to the x and then y. Notice this and that, they both have the y. I'm going to bring this to the left-hand side and then factor out the y. The coefficient right here is 1, and then once we bring this to the other side, we will have minus c3 e to the x, and then we'll factor out the y and put it at the end. I recommend you guys to put this at the end, because if you put a y in the front, it looks like y as a function of that. Yeah, but that's not what we're talking about, so this is a better form. And this right here is equal to c3 e to the x. In the end, we can just divide this on both sides, so we get y equals c3 e to the x over 1 minus c3 e to the x. Yeah, just like that. Now, it's totally okay if you just stop right here and then just go ahead and plug in 0 for x and y for 2 and then solve for c3. However, this is what we usually do, because this right here is actually a simplified version of a logistic differential equation. you see that this and that are the same, right? So we are actually going to divide this for the whole thing. So divide this by c3 e to the x, and then divide this by c3 e to the x, and then also divide this by c3 e to the x. This way, you can see that we just have to deal with the constant at one place. This right here is y, and then I'm finally done, so I'm just going to put down y as a function of x. On the top is nicely equal to just 1. Check this out. 1 over c3, it's another constant, right? Which is just c4, but we are all done, so I'm just going to put here as c. Now this normal operation we'll do, so 1 over c3, which is technically c4, but we don't need a subscript anymore. However, 1 over e to the x, which is just the same as e to the negative x. And then this is just going to be minus 1. So that's what we have. Good. Now we'll use the initial condition to solve for the c. We know y of 0 is equal to 2, which is 1 over c e raised to a negative 0 and then minus 1. Check this out. This is going to be just 1, so we just have 2 equals 1 over c minus 1, and then you can just think about like what c should be, but like if you would like, you can multiply the c minus 1 on both sides, so 2c minus 1 is equal to 1. Just do your business. And then c minus 1 is equal to 1/2, and then c is equal to 3 over 2, right? Is it? Is it? Double checking. Yeah. So ladies and gentlemen, I'm just going to write down the answer right here for you guys. Y of x is equal to 1 over c is 3 over 2, and then e to the negative x power, and then minus 1. But the problem is that, I know. The problem is that we have a complex fraction. So let's multiply the bottom and the top by 2. So finally, I promise this is the last step. Y as a function of x is equal to 2 on the top over this times this is just 3, and then we have e to the negative x, and then this times that is minus 2, and we are done. Oh my god, yes. Ooh, very cool, huh? Alright, so hopefully this video gives you a good introduction on how to solve a separable differential equation. And if you guys need more help, check out my other videos and subscribe for future videos, especially for Calculus 2 tutorials. And as always, that's it.